Okay, before we get into the specific talking about parts A and B of this one, about how we find a horizontal tangent and a vertical tangent, they start out by telling us we've got a picture that is of a graph defined implicitly, so using x's and y's. And we've got the 2x squared minus 2xy plus y squared minus 4 equals 0. So that's the equation of that function, not function, of that ellipse. And they're asking us about the tangent lines. And tangent lines should be your indication that we are talking derivative, right? That's where it's the slope of the tangent line is your derivative. Yes? Okay. So I know that there's something to do with our derivative here. So before we jump into how do we find these, let's go ahead and just go through our derivative, and then we'll talk about, okay, well, what are we going to use that for? Or how are we going to use that to help us find what they're asking for in parts A and B here? And so it's using our implicit differentiation techniques to go through that. So we would start with the 2x squared would give a derivative of that would be 4x. And then we run into a product, right? Negative 2x times y. So we'll follow our product rules. First function being negative 2x, second function being y. So first, times the derivative of y, and the derivative of y would be y prime, right? Plus the second, which is y, times the derivative of the first, and the derivative of the first would just be 2x, negative 2, right? So negative 2 times y. And then we go to our next function, y squared. Derivative would be 2y, y prime. Anytime we do the derivative of y, we follow it with y prime. Derivative of 4 would be 0, equals derivative of 0 is 0. Okay. Collect everything with our y primes. And I'm going to put the 2y first, just because I like the positive term first. Move everything that doesn't have a y prime to the other side. So add 2y, subtract 4x. Factor out my GCF. Divide by 2y minus 2x. And we could actually simplify that. They are all divisible by 2, or I could factor out a GCF of 2 in the top and bottom and simplify that out of my fraction, giving us a derivative of y minus 2x over y minus x. Okay, so there's our derivative. That would be the equation that gives us the slope of the tangent line anywhere in that picture, right? And so the first question, find the coordinates of points A and B where the tangent lines are horizontal. So then I have to think about, okay, well, if it's a tangent line and it's horizontal, so here's A, and it's horizontal, I need my slope, my derivative, to equal what? What is the slope of a horizontal line? 0. So that's how I know that I'm going to set this equal to 0, because it says horizontal, and horizontal lines have a slope of 0. So I'm going to take my derivative and set it equal to 0. And because it is a fraction, which part of it's going to be 0 if it equals 0? The top, right? So I know then I can just set the top equal to 0. And that's where this starts kind of looking weird. Well, I'm not actually getting a number answer, am I? What I'm getting is an equation that has an x and a y in it. Okay, well, step back and look at what we're looking at. We're looking at a line right here that is being described as this. Or if I solve for y here, add the 2x over, we get y equals 2x. And we've got this ellipse here that is described as this, and they meet at this point. Well, back in Algebra 1/Algebra 2, we learned that if we have two equations that cross each other at a point, we can find that point by doing a system of equations, right? And your system of equations, we learned multiple ways of how to go about solving that, graphing it, which is not going to help us here, or substitution or elimination. You remember that whole topic in algebra? Okay, well, elimination is not going to be a good option for us, but substitution is, especially because of how this is right now. At this point, I know that y equals 2x, and it would be easy for me to sub that in for y in the other equation. So we're using substitution to help us find this point where those two lines intersect. Okay? So if I go to that other equation, every place I run into a y, I'm going to replace it with 2x. So I have a y here, I replace it with 2x. I've got a y there, replace it with 2x. And now I've got an equation that just has x's in it, and I can solve for the x coordinate of that point. So cleaning this up, let's see, we have 2x squared minus 4x squared plus 4x squared minus 4 equals 0. Minus 4x squared and plus 4x squared would cancel. So we get 2x squared minus 4 equals 0. Add 4 and divide by 2. I get x squared equals 2. And this is where, again, I have to be a good algebra student. When I square root something, I get plus or minus. OK, well then does that make sense that I get two answers there? It should, because aren't I trying to find two different points where it has horizontal tangents? So that's my two x values. And now I need to go find my y values for those other ordered pairs. We'll go back up to where we were here. This is really easy. Y is going to equal 2 times our x value. So take your x value and plug it in there. Y is going to equal 2 square root of 2. Or negative 2 square root of 2. Questions on that? Okay. It is a very similar process for the second one. We just have to remember when it says that they are supposed to be vertical. Vertical lines have a slope of what? Undefined, right? And if I need my slope to be undefined, what part of it do I need to look at being a certain number? Denominator has to be 0. So that's what I would set up here to get my equation, to do my system of equations. So I just went straight to my denominator equaling 0, which gives me, add that x over, y equals x. And again, I want to know where this line, which is the blue one, and my ellipse intersect each other. So do your system of equations, solve by substitution or elimination. Substitution. Okay, we're going to sub in for y, x. So I'm going to rewrite that equation, and everywhere there's a y, I'm going to put in an x. Okay, well 2x squared minus 2x squared is gone, and I'm down to x squared minus 4 equals 0, or x squared equals 4. When I square root, I get plus or minus 2, or factor by a difference of squares here. So I get a positive 2, and I get a negative 2. Then I go back to the equation, plug it back in to find y. Well, the equation is that y equals x. So if my x value is 2, my y value is 2. And negative 2, and that would be the 2 points where we have vertical tangents. Complicated problems. I would rank those among some of the most complex we've run into so far. And not the last time we're going to see that question. Okay, so make sure that you're understanding how to find a horizontal tangent or how to find a vertical tangent, especially when dealing with implicit differentiation. Questions? Okay, your assignment is on page 169. You're doing 59 through 63, and then the AP 1, 2, and 4 is like at the end of that section. There's like a little, I think they call it AP quick quiz. It's got 4 little questions there. You're doing 1, 2, and 4 of that.